right, let's talk about something every single Java developer knows. That awful feeling when your program just stops, dead in its tracks.
I mean, you've been there, right? You write your code, you think it's perfect, it runs fine, and then, out of nowhere, bam, it crashes. No warning, just gone.
So, let's start with the happy path. This is when everything goes exactly as planned. We've got a super simple line of code, int result equals 10 divided by 2. No problem, right? The program crunches the numbers, prints out result, 5, and just keeps on trucking. Perfect.
But what if we change just one little thing? Instead of dividing by 2, let's try dividing by 0. Now the program doesn't just give you a weird answer, it completely crashes. It throws what's called an arithmetic exception, and the whole thing just stops. Done. It's kind of crazy that one tiny mistake can bring the entire program to a halt, isn't it? So in this explainer, we're going to get to the bottom of this. We'll look at why good code suddenly goes bad. We'll dive into Java's built-in alarm system. We'll talk checked versus unchecked exceptions, see why you should never just swallow errors, and finally, figure out how to build way more robust code. Okay, first up, when good code goes bad. Let's really dig into that crash, because it's not just some random bug. It's actually a very specific, deliberate event that Java is designed to trigger.
Which brings us to the big question, right? Why does the program just stop completely? I mean, why doesn't it just, skip that line and keep going? Why the total shutdown? Well, the answer is a core part of how Java is built.
And that leads us to our next section, Java's built-in alarm system. The key here is to stop thinking about this as a failure. It's not. It's a deliberate alarm system. Java is basically screaming at you that something really, really important just went wrong.
And that something has a name, an exception. It's not just a message, it's an actual object in Java. It's a little package of information that represents some kind of abnormal or, exceptional situation. And the second that object gets created, the normal flow of your program is toast.
This is actually a perfect way to think about it. It's like a fire alarm. When a fire alarm goes off, it doesn't just make a little polite beep. No way. It's loud, it stops everything, and it forces you to pay attention right now. That's exactly what an exception does. It slams the brakes on your program because if it kept going, who knows what could happen? You could get corrupted data or all sorts of unpredictable, crazy behavior.
And here's the thing, it's not just random chaos. This whole alarm system is super organized. See, everything that can possibly go wrong and be thrown in Java belongs to this big family tree. It all starts with the Throwable class. From there, it splits into two main branches, error and exception. Now, errors are the really big, scary things, like your computer running out of memory, stuff you usually can't do anything about. But exceptions? Those are the things we, as programmers, can actually anticipate and handle. They're problems within our application's logic.
Okay, so now that we know there's a system, let's talk about the rules of engagement. Java splits exceptions into two big categories, and understanding the difference is absolutely crucial.
So here's the deal. You've got checked exceptions and unchecked exceptions. Checked exceptions are the ones the compiler itself worries about. It checks them when you're compiling your code. These are for problems you can kind of see coming but are outside your direct control, like trying to read a file that isn't there. The compiler literally will not let you compile your code until you've said how you're going to handle it. Then you have unchecked exceptions. These are the surprises that pop up at runtime. They almost always point back to a bug in your logic. Yep, like trying to divide by 0. The compiler doesn't force you to handle these because, the real fix is to write better code so they don't happen to begin with.
Okay, so we know the rules. Now let's talk about what happens when developers break those rules in the absolute worst way. This is a huge no-no in programming, a real case of coding malpractice. It's a practice called error swallowing. Basically, your code catches the exception, it hears the alarm, and then just does nothing. It's like walking over to the fire alarm, turning it off, and going back to your desk like nothing ever happened.
And this is what it looks like. This is the classic sign of the crime, an empty catch block. The code failed, the alarm went off, the exception was caught, and then just silence. The program just keeps chugging along, pretending it's all good. But it's not at all.
And you have to understand, this is so dangerous. You're not fixing a problem, you're just hiding the evidence. So when your app finally does crash and burn later on, and trust me, it will, you'll have absolutely no clue why. The original problem, the root cause, is just gone. It turns debugging into an impossible nightmare,
and can bring down your whole application.
So let's flip this around. How do we do it right? How do we use this alarm system to our advantage and build code that's actually stronger and more robust?
Okay, here are some essential best practices. First off, don't use exceptions to control the flow of your program. They are for exceptional things, not for everyday logic. Second, be specific. Don't just catch the generic exception class, catch the exact one you're expecting. Third, and this is the big one, never ignore an exception. Never. At the absolute minimum, you have to log it so you have a record of what went wrong. And finally, stick with the standards. Java gives you a whole toolbox of standard exceptions. Use them. It makes your code so much easier for everyone to understand.
And this really gets to the heart of it. We need to change how we think about exceptions. They aren't just annoying errors that crash our code, they're signals. They are a powerful feature of the Java language designed to help us build safer, more resilient software that can actually handle it when things go wrong.
So, when you think about it, the question isn't if you'll run into exceptions. You will. The real question is, what are you going to do about it? Are they just a nuisance you try to silence? Or are they your best tool for building seriously tough, resilient software? Next time, we're going to show you exactly how to handle them with things like try-catch blocks, so your program can recover gracefully instead of just crashing.